Hi guys, welcome back to Builders and Academic Tutorial. Today I'm going to be considering question under chemistry alternative to practical in preparation towards 2025 examination. And today we're going to be looking into question under volumetric analysis because chemistry practical contain 3 questions. The first one is volumetric analysis, the second one is qualitative analysis, and the third one is a general question under chemistry that's related to your practical knowledge of chemistry. Now today, the question one before us says a volumetric analysis 24.80 centimeter cube of 0.100 molarity, that is mole per dm cube, of a mineral acid Y neutralize 25 centimeter cube of an alkaline solution containing 5.80 gram of sodium triosocarbonate 4 per dm cube. Now, what does this mean? It means that in this question, in the volumetric analysis, a student carried out a volumetric analysis and it was discovered that about 24.8 centimeter cube volume of the concentration of mineral acid Y. For mineral acid Y, we are given mineral acid Y, mineral acid term Y. Then we are told that the volume of that mineral acid that was used was, I would call it VA. The volume of the mineral acid used is 24.8 centimeter cube, and the concentration in mole per dm cube is 0.100 mole per dm cube. So we have the concentration of the acid to be 0.100 molarity, that is mole per dm cube. Mole per dm cube and molarity, they are the same unit. So I'm going to be using mole per dm cube according to the question here. So mole per dm cube. Now, they now said this volume and this concentration of the word acid neutralize 25 centimeter cube of an alkaline solution containing 5.80 gram of sodium carbonate 4 per dm cube. Now look at this statement. The volume of the word alkaline solution is 25.0. So it means the volume of the pipetted word sodium triosocarbonate what? Sodium triosocarbonate 4. The volume pipetted is what? VB, which is 25 centimeter cube, and it contains 5.8 gram per dm cube. Listen, 5.8 gram per dm cube. It is saying something to us. It is a concentration in gram per dm cube. So this concentration given to us, 5.8 gram per dm cube, is a concentration in gram per dm cube. That is the solution of what? Of sodium hydroxide, sodium triosocarbonate 4 that was dissolved in a volume of 1 liter of water. The volume of 1 liter of water. So this is a mass concentration. That's what I'm trying to say. It's a mass concentration, not molar concentration. It's a mass concentration. So I'm going to write mass concentration of sodium hydroxide given to us, of sodium hydroxide. Sorry, why am I saying sodium hydroxide? This is sodium triosocarbonate 4, which is 5.8 gram per dm cube. 5.8 gram per dm cube. 5.8 gram per dm cube. Now, having known this information now, they said from this information, calculate the number of moles of Y. Calculate the number of moles of Y. Now, the first question here is A Roman figure 1. We have to calculate number of moles of Y. Number of moles of Y. And how do we go about that? Number of moles of Y. The first thing you have to look at is that we are given what? The concentration of Y. Concentration of Y, which is the molarity. And note that molarity Ca now is named as mole over what? Over volume. Usually in dm cube. The volume is always in dm cube. Note that. So to get the mole now, you just have to do cross multiplication here. Volume multiplied by what? The concentration to get your mole. So don't forget that the volume we are talking about here now, will be the volume of the what? Of the acid used, the volume of the acid used to neutralize the alkaline solution. So to get your number of moles now that we're looking for, number of moles of Y now, we now be what? The concentration A multiplied by the volume A. That's going to be the volume A. So, but this volume is in centimeter cube. So to take it to dm cube, 1000 centimeter cube make 1 dm cube, or we can say 1000 centimeter cube make 1 liter, because 1 liter is equivalent to 1 decimeter cube. So 1000 centimeter cube is equivalent to 1 dm cube. So what we are going to do is that you are going to convert this volume from centimeter cube to what? Dm cube, by dividing by 1000. So this is going to be what? Divided by 1000. So concentration times volume over 1000. So that's what we are doing. So number of moles of Y now will be, number of moles of Y will be 0.10 multiplied by the volume 24.80 divided by 1000 to get it in. Now I'm going to use my calculator here. So 0. I think it's going to be 0.10 times 24.8 divided by 1000. That will be 0. This mole is going to be 0.00248 moles. That's the moles of what? Of Y. 0.0248 moles of Y. Now the second one said the number of moles of sodium triosocarbonate 4. Number of moles of sodium triosocarbonate 4. So what I'm going to do now, for sodium triosocarbonate 4, that is from our figure 2. Number of moles of sodium triosocarbonate 4. What you're going to do is that you are going to use the same formula. Molarity is equal to moles over volume. But before we do that, do we have molarity of sodium triosocarbonate 4? That's the first question you need to ask yourself. We know that molarity is always, in this case, you are looking for number of moles of sodium triosocarbonate 4. So it's going to be what? To use the formula molarity now. Molarity CB now, because we are looking for B. I use B to denote for sodium triosocarbonate 4. So CB is going to be what? Number of moles of sodium triosocarbonate 4 all over the volume of the alkaline solution used. Volume of the alkaline solution used, of alkaline solution, the total volume of alkaline solution. So of alkaline solution, whatever we want to be, details of alkaline solution in dm cube. Don't forget, it's always in dm cube. Always in dm cube. We always use this volume in terms of dm cube. So now, so what we are going to do is that we need the CB, because we are never given CB. CB is molarity in mole per dm cube. So we need to get molarity in mole per dm cube. But we are given what? Molarity. We are given mass con of sodium triosocarbonate 4. So to get the molarity or the molar con of what? Of sodium triosocarbonate 4, we are going to use this formula. This is the important formula that you need to know. Molarity of the compound, or mass concentration, whatever you wanted to call it, is molarity of a compound, or molarity of sodium hydroxide, sodium triosocarbonate 4 is going to be mass con over molar mass. Please note this. Molarity of sodium triosocarbonate 4 of any compound, but this case is sodium triosocarbonate 4, is going to be mass concentration over molar mass. And what we are going to do is that we are going to say that the mass concentration here is 5.8 gram per what? Per dm cube. And then I'm now going to find the molar mass of sodium triosocarbonate 4. So let me put it here so that you know what we are using. Sodium triosocarbonate 4, and then molar mass of sodium triosocarbonate 4. So what is the molar mass of sodium triosocarbonate 4? Because of my time, I will do it straight. It means the what? The addition of individual atomic mass of element that made up of what? Sodium triosocarbonate 4. That's what are the elements that make up sodium triosocarbonate 4? We have sodium, carbon, oxygen. So what is sodium? What is atomic mass of sodium? That is 23. Atomic mass of sodium, we are going to be given sodium is 23. So to find the molar mass of sodium triosocarbonate 4, you are going to be adding the mass of what? Of sodium with the mass of carbon with the mass of oxygen. So the molar mass is going to be 2. Look at this, sodium here is 2. The sodium in sodium triosocarbonate 4 is 2. So 2 times 23 plus carbon is 12. I'm going to be using 12. 12 plus 3 into bracket 16. Bracket close. Don't forget the unit. You are expected to do this separately, but remember, I'm trying to save time, so I'm going to put the unit here, which is gram per mole. Gram per mole. So we are having the mass concentration and we're having the molar concentration here. So what you are going to have here is going to be 5.8 gram per dm cube. When you add everything together, you should get 106 gram per mole. So let's see what we get if we divide this. This is going to be 5.8 divided by 106. This is going to give us 0. Divided by 106. This is going to give us 0.054. 0.054. Let's reduce it to 3 decimal place or 4 decimal place. So in mole per dm cube, this is going to be mole per dm cube. Please always put the unit. It's very, very essential. Mole per dm cube. So this unit here is very, very essential. So how we get is that this one cancel out. So the mole goes up to give mole per dm cube. So if you cannot express it in such a way that it is, just write 5.8 divided by 106 and then you write 0.547 mole per dm cube. This is very, very important. The unit here is very important. Mole per dm cube. So that's that about that one. So what I'm going to do now is to continue these questions, and I'm going to be rubbing this off a little bit to create a space for myself. So I'm clearing this off from here. We've done number 1. We've done number what? So the next thing is to now, we've gotten the molarity now. We can now come back to this formula that I've written here. The molarity of a compound is moles of sodium triosocarbonate 4 over the volume of the alkaline solution, that the total solution given to us. So we are now having what? Okay, so this is the formula, but what we are looking for is, this is the formula for molarity, and what we are looking for in this formula, what we are trying to use out of this formula is number of moles. Don't forget, the question says number of moles of sodium triosocarbonate 4, and to get sodium triosocarbonate 4, the number of moles of sodium triosocarbonate 4, we need the formula, we need the molarity, value of molarity, and that's why I go through this process to get the molarity, and then I'm coming back to this formula to get my moles. So number of moles of sodium triosocarbonate 4 will now be equal to volume, the CB times the volume, B all over what? 1000. Don't forget, divide by 1000 to take it to dm because they give us in centimeter cube. So your CB now is what you just get here. Don't forget this CB, which is the molarity of sodium triosocarbonate 4, is also tag CB. So we have what CB is going to be 0.0547 times, what's the volume given to us? The volume of B given to us is 25 divided by 1000. So we cannot do that. So what do we have for this number of moles of B? So we have 0.0547 multiplied by 25 divided by 25, 0.0547 divided by 25. So answer now. So we have this. So we're now going to have 1 point. Is that divided by 1000 now? So we're having 0.00136. You can leave it to 4 decimal place. 4 decimal places is enough, but because we wanted to have good answer, because this is 2 decimal place, this is still at 0.0136. You can leave like this and then do your approximation to be 0.001. Okay, let me say 137, because we are going to be using this for subsequent questions. So that's why you need to have a better form of this, not to have a restricted answer. So that's why I take time to write the number out, then approximate it to this. So this is what 0.0137 moles. So that's that. So for the number of moles of sodium triocarbonate 4. So the next question, you can see, the next question is to look for the mole ratio. The mole ratio, we have to calculate the mole ratio of acid to base. Now, the mineral acid is your acid, so this Y is your acid, which is A, and this is your base, alkaline solution that contains this. This is your base. So we have to calculate the mole ratio of acid to base. Mole ratio of acid to base. There is a formula that we usually use in this volumetric analysis, a standard formula, CA VA over CB VB all equal to NA over NB. So it actually gives you a straightforward of how to do mole ratio. So mole ratio is just that you can easily do it even from here, from what you get, because you have gotten your moles for A, you got your moles for B. You can just leave it divided together. Just use A divided by B, and then you get mole ratio. But you can also use this formula, CA VA over CB VB equal to NA over NB. So that formula itself is very straightforward, but because of my time, I will just use this mole ratio directly to do that. So the mole ratio now, the mole ratio is gonna be the ratio of acid, right? Acid moles over what? Over base moles. That's what it means by moles ratio. What's the acid mole? The acid mole that you get is 0.02420 come first. Okay, 0.0248 divided by, I would like to use this one. This is a better form. 0.00. That's why I'm saying you should just first write it out first, so that you can have a good answer. So since I know what is next, so I'm just going to clean this. So what do you have for your mole ratio now? What do you have for your mole ratio? Let's press my calculator. So we have 0.00248 divided by 0.00248. 0, 1, 3, 6, 7. So we have 1 point. So meaning that when you say mole ratio now, how many of these did I have in this? This is going to be 1. This is going to be 1.81. So the ratio is this one. If we say how many of these we have, we are going to have 1.81. So we are going to be having 1.81 of A to B. So this is going to be your A, this is going to be your B. Approximately, this simply means, if I approximate this one, this simply means 2 ratio what? 1. So it means we have the mole ratio of A to B is 2 to 1, because ratio usually is in whole number. So you approximate to the nearest whole number. So approximate to the nearest number, this one is going to be what? This is going to be 2, and this is going to be what? 1. So that's what you are expected to what? To do. That's what you are expected to do. So what you are going to do now is to move to the next questions. And now say, what is the basicity of acid Y? What is the basicity of acid Y? That is the question here. What is the basicity of acid Y? So I'm going to clean this. Finally use this one. Finish. So that I can have better space to answer the questions. So the question says, what is the basicity of Y? What is the basicity of Y? What is the basicity of Y? That's the question. What is the basicity of Y? What do you mean by basicity when you're talking about basicity? Basicity of Y, which is an acid, is the number of replaceable hydrogen ion of the acid. Basicity of an acid is the number of replaceable hydrogen ion of that acid. Now, when I mean replaceable hydrogen ion, acid is likely, like acid usually contain hydrogen, because acid in itself is defined as a substance which, when dissolved in water, produce hydrogen ion or hydrogen ion as the only positive ion. So that's why they have hydrogen in them. They have hydrogen ion in them. For every acid have hydrogen ion. For example, if we take H2SO4 now, or HNO3, or HCl, these all have, this one has 2 hydrogen, this one has 1 hydrogen, this one has 1 hydrogen. So that's the basicity. So you can say this basicity of this one is 2. The basicity of hydrogen here of this acid, which is nitric acid, is 1. The basicity of what? Of hydrochloric acid is also what? Is also 1, because the hydrogen here is 1, the hydrogen here is 1, the hydrogen here is 2. So what is the basicity of Y now? According to what you have done so far, what is the basicity of Y? You can only know that when you can predict Y. The basicity of Y is known when you are able to predict what kind of acid will Y be. And how do you predict the kind of acid Y is? Now, let's come back to the reaction. We are told that Y, I'm just trying to write it out now. We are told that Y plus sodium triococarbonate 4. We don't know what's going to be our product, but we know that they are in 2 ratio what? 1. They are in 2 ratio 1. Now, it means that it requires 2 of these to react with this. So, now, and we are told that Y is a mineral what? Mineral acid. So these are things you need to take consideration of. Y is a mineral acid. We only have 3 mineral acids, which are just listed here. Sulfuric acid, nitric acid, and hydrochloric acid. These are the 3 mineral acids that we have. But which of these can combine in 2 ratio 1? Which of these can combine with sodium triococarbonate 4 in 2 ratio 1? If you put this H2SO4, it can never be in 2 ratio 1. Why? Because you don't need, it only requires 1 mole of what? H2SO4 to actually what? React with sodium triocarbonate 4 if you write the balance reaction. So, for instance, now let's see. Let's write it out so that I won't we're saying something. SO4, H2SO4 plus Na₂CO₃ will only give you this way. This 2 hydrogen will reduce with this 2 hydrogen. What it's going to get is that since you have 2 here, 2 here, so it's going to be Na₂SO4. The salt will be formed plus CO2 plus water. This is what we are going to get when this is this. So it's going to be it's balanced already. They are going to be in this is going to be a 1:1 reaction. 1:1 reaction. So meaning that it does not fulfill this condition that we just got in from a calculation. So this can never be your what? This can never be your answer. This acid can never be your Y. Are you getting what I'm trying to now? Because it said you should what? You suggest what Y is likely to be. So as this one cannot be your Y because it does not obey 2:1. This is 1:1. The number of mole of this is 1:1. So 1:1. So it doesn't be like, so this cannot be your what? Your acid. And the basicity of this acid is 2. Since this is not the acid, we don't even consider, we don't need to consider the what? The basicity. So we consider the next one, which is HNO3 plus sodium trioxocarbonate. Let's see what we are going to get. So this is having NO3, right? So to get NO3 here, you already have, so we are going to have salt first. Don't worry. The first thing is to have salt because there is a reaction between acid and base. So the first thing you are going to have is salt plus CO2 plus water. So that's what you're going to have first. So this is the reaction. But to balance it up, you're going to need 2 here at the back here. Because you need 2 of NO3 to make up of sodium, 2 of sodium. So you're going to have 2 here as well to balance it. So this is in form of 2:1. So Y can be HNO3. Y can be HNO3. Y can be HNO3. Now let's consider what? Let's consider Y can be HNO3. So because it fulfills the rule of 2:1 of this, then let's consider HCl. HCl plus sodium trioxocarbonate, what? 4. You are still going to have salt here. You are still going to have salt. The salt here is going to be sodium chloride plus CO2 plus H2O. So now you still need 2 of this sodium to balance up. So I put 2 here and chlorine. So this is also in 2:1. It's also correct. So now this is also correct. Meaning that the base, you can see both. You can see now that both HCl and HNO3 that fulfill 2:1. They both fulfill 2:1. They both have one replaceable hydrogen. So the basicity of Y is definitely what? Going to be one replaceable hydrogen. That is 1. So it only contains one hydrogen. So the basicity is 1. So the basicity of Y here is gonna be 1. So number 1 is that this B Roman figure 1 is basicity of Y is 1. And Roman figure 2 is that suggest what Y is. You have already said Y can be HNO3 or HCl of the thing, or you can even say both. Or both. So it can be what? HNO3. Is that they use HNO3 or HCl? If you write any of these or you write it, you are not going to be what miss. But it's better you write it too. You can say HNO3 or HCl. It shows that you have the understanding of the what of the question. So that's that about question number 1. Yeah, the second question said in a titration, 23.4 centimeter cube of A contain 15 gram. A contains 15 gram of ethanoic acid. This is ethanoic acid per dm cube. So this A, which is of volume 23.4 centimeter cube, contain 15 gram of ethanoic acid per dm cube. So there's a statement that is very, very important here. We have volume of A, always write it out, 23.4 centimeter cube. And because it said 15 gram per dm cube, this is automatically called mass concentration. Mass concentration is always in gram per dm cube. In gram per dm cube. So it's going to mass concentration of A now. Of A, which is ethanoic acid, is gonna be 15 gram per dm cube. 15 gram per dm cube. So 15 gram per dm cube, that's the mass concentration of A, ethanoic acid, 15 gram per dm cube. So that's what the first two statements. They now said was reacted with 25 centimeter cube solution of B containing X gram of sodium trioxocarbonate 4 per dm cube. So your B here is X gram of your B here is S gram. Your B is S gram. So the mass conc of B, which is in formos, which has sodium trioxocarbonate 4 dissolved in solution, is equal to S gram per dm cube. That's what it said. S gram per dm cube. And then the volume of B used. Volume of B used is 25 centimeter cube. So it means the pipette 25 centimeter cube of B. So now they now give us the equation of reaction, which is very, very important. Now 2-ethanoic acid reacts with what? 2-ethanoic acid in 2 ratio. This is 2:1. It's also very, very important. This is going to be 1 because there's no number there. So we take it for 1. So this is 2:1 reaction. 2:1 reaction. So now we are now told that from the information provided, calculate the concentration of A in mole per dm cube. Calculate the concentration of A in mole per dm cube. So the concentration of A in mole per dm cube, without wasting much of our time, is molar concentration or molarity. Concentration of A in mole per dm cube. What does it mean? It means molarity of A, or molar concentration, which is I give you as mass conc of A over molar mass of A. Molar mass. So it's going to be what? Molarity is mass conc of A over molar mass. So we are going to have your conc in mole per dm cube. Your conc in mole per dm cube to be equal to, now, what's the mass conc of A? Don't forget this is A. I've already highlighted. A is ethanoic acid, right? A is ethanoic acid. So mass conc of A is going to be 15 gram per dm cube. That's the mass conc of A. But what's the molar mass of A? It means that we are going to add all the atomic mass of this formula, all the atomic mass of this individual element in this formula. Get your molar mass, just like we did the other time. So the compound, the compound contains 2 carbon, 1, 2. So we have 2 carbon there. So 2 into bracket 12, because 1 carbon has atomic mass of 12. So 2 times 2 12. That's the 2 for the what? For the 2 carbon there. So plus, how many hydrogen you have? This hydrogen 3 plus 1 hydrogen making 4. So 4 into bracket. The atomic mass of hydrogen is 1. So 1. So it's gonna be 1. 4 into bracket 1 plus. Now we have how many oxygen here? 1, 2. So it's going to be 2 into bracket 16. Atomic mass of hydrogen is what? 16. So that's it. So we have 4, 2 carbon, 2 into bracket 12, 4 hydrogen, 4 into bracket 1, and then 2 carbon, 2 into bracket 2 oxygen, 2 into bracket 16. So this is going to be gram per mole. So we're going to have 15 gram per dm cube divided by 24 plus 4 plus 32 gram per mole. So I'm using calculator now to calculate my stuff. So I have 15 divided by 24 plus 4 plus 32. So we have 0.25. That's the answer. 0.25. 0.25 mole per dm cube. That's this for this. Now the next question is the concentration of B in mole per dm cube. The concentration of B in mole per dm cube. The concentration of B in mole per dm cube. What is the concentration of B in mole per dm cube? The concentration of B in mole per dm cube. So we are asked to calculate the concentration of B in mole per dm cube. So we are not given mass conc here, so that we can be able to use this formula. So meaning that we cannot use this formula to get mass to get concentration of B in mole per dm cube. So this formula here is not going to be applicable to the solution B. So what we are going to do in this case is that we look for another method of solving the molar conc for B, that is concentration in mole per dm cube. So to do that, which is the concentration of B in mole per dm cube, now we're going to be using another formula: CA, VA, CB, VB. This is the formula I was telling you the other time that we usually use for solving what number of moles. You can see the concentration times volume is equal to number of moles of what? Acid. The concentration of base times the volume of base is equal to number of moles of base. So that's something you need to note. So now the concentration of A has been gotten from here, which is concentration of A is 0.25. So put it, I'm going to be managing this place. So it's going to be 0.25 multiplied by the VA is 23.40 all over. Now what is the CB? Is that what we're looking for? Don't forget, this is what we're looking for. Multiplied by VB. VB is 25. Definitely they give us 25. Then what's the mole ratio that I would say the other time? The mole ratio is 2 to 1. Acid is 2. This is acid, and this is base. You can see the mole ratio is 2 to 1. The number here is 2. The mole ratio here is 1. The mole here is 1. So we are going to write when the acid is 2 over 1. This is equal to 2 over 1. Please note that 2 equals to 2 over 1. So by cross multiplication, the 2 by cross multiplication, let me use this. This multiply this, and this 1 multiply this. So we are having something like this: CB multiplied by 25 multiplied by 2 equal to 0.25 multiplied by 23.40 multiplied by 1. So I don't need to put that one because it's 1. So divide both sides by 25 times 2. Divide both sides by 25 times 2. So this one cancel out. What's going to be my B? Let's quickly press down the calculator. So I'm going to be having 0.25 times 23.40 5 by 25 times 2. So 0.25 times 23.40 times 25 times 2. So this is going to be 0.117 mole per dm cube. So that's it. So that's that about that. So successfully get that. So what we're going to do next is to get the next question correctly. Now the next question is the concentration of B in mole per dm cube. So we've gotten the the concentration of B in mole per dm cube. So the next one is the value of B, value of X, sorry, the value of X. So the next question is to get the value of X. We've gotten the concentration of B in mole per dm cube. The next one is to get the value of X. The value of X is the same thing as what? Mass concentration. So we can now use this formula now. Look at this. This formula that I use for A count is also be applicable to this. We have the concentration of A equals to mass concentration over molar mass. So the only thing you can just do is to make mass concentration the solid formula here to get that of mass concentration for B. Are you getting? So what I'm going to do is I'm going to say mass concentration, which is what I'm looking for, gram per dm cube. Mass concentration of B now is going to be equal to concentration of A. Sorry, concentration of B rather now, because we are talking about B. I'm just trying to show you that this formula can be applicable when you have all the necessary parameters, because we have gotten the concentration of B in mole per dm cube now. In mole per dm, concentration of B in mole per dm cube has been gotten with this molar concentration. So times what? Molar what? Mass of B. So that's it. So to get the mass concentration, we are using this formula. It's just that the difference is just that we are dealing with B here. So the mass concentration of B is equal to concentration of B multiplied by molar mass. So what you're going to do is, we're going to say, okay, concentration of B. What is concentration of B? This is 0.117. Concentration of B is 0.117 multiplied by what is molar mass of B. If you have molar mass of B, molar mass of B is this. So to get molar mass of B, you are going to calculate, you are going to sum up the atomic mass of sodium triocarbonate 4, which we did previously, which is 106. Go and look at the first question that we did. It was 106. Sodium triocarbonate 4 is 106. So I will not waste most of our time here. Just put 106 gram per mole. So this is going to be, but you are advisable to do this one by one. It has been done in the first question. That's why I don't want to repeat the process. You are going to write the sodium times 223 plus what? Carbon 12 plus 16 times 3, which is 46. So we're going to get 106. So 106 times 0.117 is going to give you the what? The answer 106. So we're going to multiply now 0.117 times 106. So we have 12.402 gram per dm cube. That's the value of what? Yeah, that's the value of X. X is equal to this. So that's that about the questions. Please, if you haven't subscribed, please do press the subscribe button and notification bell. That's our update on this YouTube channel. We are going to be doing other videos on mathematics, physics, chemistry, and another subject like economics, geography. So you don't want to miss out. Please do subscribe. See you next time.